Hello, and welcome to the next latest and greatest webinar on CIS-211, Principles of Computer Programming 2 here at GMC. I am Professor Lusby, and I wanted to make another weekly webinar recording here that is going to go over week 3. We are in week 3 of the course, and we're going to start to get into some really interesting / industry relevant material now that we are further along in this course. I assume all of you are comfortable and familiar with the classroom by now. If you missed any of my previous weekly webinars, they are here posted to the top of the classroom. Please check those out. But I'm going to go ahead and dive in because we've got a lot to talk about this week. The only other really important link that I always like to point out is this glorious virtual desktop that has everything needed for your assignments for this course, right? And I'm going to be demonstrating how to use this here in just a second when we go over what it is that we need to do. So with that said, I'm going to go ahead and go down here to week 3, and we are going to see that week 3 is about right, exception handling, for sure, and file parsing. These are two very important topics in the real world and industry. Why? Because a lot of times we want our program to get the input from a file, and other times we also want to send the output to a file, right? We don't want to have to be typing our data in all the time every time we want to run our program, especially when we scale up and all of a sudden we have millions of records of data. For sure, we don't want to be typing all that in. So knowing how to do what's called file parsing to read data into a file, read data from a file is very important, and knowing how to output to a file is also very important. So that's kind of the high-level objectives of what we're trying to do here in week 3. Notice that we are going to be focusing in on chapter 11 of your textbook, which is exactly over exceptions and I/O operations. And if we take a look at that here in your textbook, in particular, we're really going to be focusing in on the first half of this chapter. Obviously, the second half of this chapter, basically the way they broke this up is reading and writing the text files is basically here from 11.1 to 11.8, and then from 11.9 down here to 11.12, this is reading and writing to binary files. Both are used in industry, but we are really going to focus in on this top part here for our, I believe, discussion and even our programming assignment. Not to say that this isn't important too, right? Of course, your quiz questions over chapter 11 this week can come from this material as well, but at least for this webinar, I'm going to be focusing in on this. High level, what's important out of here is that when we're talking about file I/O, anytime that we have to read in data from an external source or even write data to an external source, there's always something that could go wrong, all right? Because the program isn't in control of the hardware, right, of the hard disk that reads and writes to these files. So anytime you have something that is outside the program that can go wrong, or maybe the user types in some data wrong, that's what exceptions are for. Exceptions are there to enable you to catch some really weird errors, like let's say you can't read or write to the disk, right? Like let's say you can't cast a particular string to an integer. These are all kind of unusual circumstances that exception handling needs to be added for, and that's why it talks about exceptions here at the beginning. We haven't really used exceptions yet, but for sure, if we're doing file I/O, we will be utilizing exceptions. And notice how many different kinds of exceptions there are, and there's even more than this. But at the end of the day, if you use a class that throws an exception, you'll see it in the documentation. It'll basically say, hey, here's the class, here's the API, but these possible exceptions can be thrown. And even with some of these file I/O classes, you have to implement the exception logic or it won't compile. So keep that in mind that exceptions are very important and they follow this format here, where any code that might generate an exception, all right, and again, that'll be in the documentation for whatever class that you're using, needs to be wrapped up into a try block, right? So we see the keyword try, we see the curly brackets, and any code that might throw an exception needs to go here inside of the try curly brackets. If the exception occurs, if for whatever weird reason that exception occurs, it's going to transfer control down here to what's called the catch block. All right. And this catch block, this is where you specify the exact exception that you're listening for. This catch block will basically execute this code in between these curly brackets. And you can do whatever you want. You can basically print an error to the screen and say, hey, I can't read to the disk. Hey, I can't write to the disk. But there's also other ways to handle an exception. You could set some default values so that the program continues to run and the user doesn't get frustrated. But the key here is that when you're using exceptions, when you're using classes that contain exceptions, you have to implement this. Well, not for all classes, but for a lot of classes, you need to implement this try-catch logic. And if you don't, then at runtime, and if an exception occurs, it just crashes the whole program. So at least the try-catch block enables you to catch these exceptions and handle them gracefully, versus you don't have this try-catch code and an exception's thrown and it just crashes the whole program. So, and they show you an example of this here, right? If for instance, this toString method can throw this file not found exception. And if you're not listening for it, if you don't have a try-catch block for it, yeah, you're going to get this big error dump to the screen that's basically going to say, well, I can't do anything else because an exception was thrown and I can't find any try-catch exception logic to handle it. All right. So anytime a class throws an exception, typically you want to listen for it with a try-catch block, or you also have the option of handing it further up the hierarchy to the person above the class calling it. Okay, but that's later. That's a little nuanced, and I don't believe we're going to get into that at least yet. All right, so here's a good example here in 11.1. Remember, we always have a main method. We have our class. Here is where they're creating code that will listen, that will create a file, okay, or at least try to create a pointer to a file called data.txt, and then create a scanner that we are going to use. Remember, we were using scanners before to allow the user to type in input, right? Well, we can use the same scanner, right? Instead of asking the user to type in, we can say, hey, use the input file instead. Pretend that input file is the user basically typing in data. So for file parsing, at least in Java, you almost always see some sort of file object because that points to the file you're going to use. And you must always see the scanner object because that parses that file. That is responsible for reading and interpreting that file. The other thing that I like about this example is because we don't really know how much data is in that file, this is pretty typical for a file parsing algorithm where you have a while loop, right? Remember that we create while loops anytime that we don't know how many times it needs to loop, all right? And the way that we know if we need to keep looping is we can use this scanner guy and say, hey, look at the file, right? Because input file is passed in a scanner, and does it have another integer value inside of it that we can read in? Has next int. If this is true and it has data, this isn't actually reading the data. This is just looking at the file saying, okay, is there more data there that I can read in? If this is true, then it goes inside the loop. And at that point, we say, okay, fine, grab the next integer out of that file, right? And then put it into a variable here called number. And it basically keeps looping, looping, looping until it reaches the end of this data.txt file. Has next int returns false because there's no more integers inside that file. We've read all of them out. And once this is false, well, then the while loop is done and the main program is done. So this is the main program here. This catch guy, this only occurs if as it's trying to read this data.txt file, it can't find it, right? If it's trying to read this data.txt file and it can't find it, it's going to throw a file not found exception, and immediately it's going to transfer control down here to this catch block. Notice what this catch block does. It basically prints out a message saying, hey, I got this error, this file not found exception error. Inside of this file not found exception error is a nice friendly user message called get message that will allow us to see what exactly that error was. And then, yeah, I mean, essentially what's going on here is it's printing out a user-friendly string that's going to let us know why that file could not be found. All right. And then finally here, there's something called a stack trace. So when a program crashes, typically because of an exception, or if an exception is thrown, the exception typically has stack trace information in it as well. And you can use that stack trace to see what line of code caused that particular exception. And this is important in industry. When you release code and an exception is thrown, you want to take that stack trace and basically send it back to whoever the company is that made the software. And if that company receives that stack trace, well, now they can troubleshoot, try to recreate that exception, and make the software better. All right, so I think that's one of the reasons why they're showing us this print stack trace option here. So lots going on here. At the end of the day, at least for your assignment, what's key here is that you have a try-catch block, right? You're creating a file, you're creating a scanner, and we're going to go into that a little bit more later. You've got a while loop that keeps looping until there's no more data, and you've got a catch block, and you don't have to get this fancy with the error. You can just say, print could not find file, right? But this is all definitely good information, especially for industry that you can help to improve the product later. All right. So high level, this is a common algorithm that is used to read files in Java using the scanner. All right. There is a way to catch multiple exceptions. Some of these classes throw more than one exception, right? Because maybe, yeah, you can't find the file, but maybe the file's corrupt, right? Maybe there's a file corrupt exception. Maybe, there's 100 reasons why when you have to look to the outside world for data, there's 100 different reasons why that data may not be there or it may be corrupt. So if you want to catch multiple exceptions, just know that you can line up these catches one after another underneath the single try block, and you can try to catch each one of those different exceptions. They also add this new finally block, and this is here, yeah, basically executes regardless of whether an exception occurs or not. So this is good for if you're doing file processing, no matter what, at least try to close the file at the very end, right? In your try block, you're going to be opening it up. But if an exception occurs and it transfers control to here or here, you still want to at least try to make an attempt to close the file before uh, you complete whatever logic is here. So for sure you need to know about try, catch, and finally. All right, so that is 11.2 here. 11.3, reading text files using a scanner. And we're going to be talking about this for our discussion, for our week 3 discussion here in just a second. But notice that the scanner, remember the scanner guy, if we pass it a file, all right, if we pass it a file, we have all these nice, wonderful methods that we can use on the scanner in order to obtain information from that file. Next, right, all these next guys, well, at least these two, return I believe it returns a string. Oh, this is has next, excuse me. So the has guys return true or false if there's a string available, if there's an int available, if there's a double available, if there's a float available. It's going to return either true or false if there's further values in these files. If you know that there's data in the file because you ran one of these and it says, yeah, it's true, there's definitely some data there, then you use these guys here. Next, next line, next int, next double. These actually return the real data using the proper data type. So if it's the next line of data is a string, well, then you're going to use next line. It's going to return a string. If the next piece of data is an integer, well, you're going to use next int, and it's going to return an integer. All right, so it is very important that we understand what these text files look like when we're trying to read them in our program, because we need to know, was the next value an int? Is it a float? Is it a string? Because if we try to read in, let's say, a string of data using next int, well, then that's going to throw an exception, probably input mismatch exception, and your program's going to come to a grinding halt. And again, I'll demonstrate this here in just a second when we get to our discussion. Speaking of which, maybe that's what we're going to do. Let's go ahead and talk about the week 3 discussion. Just know that in chapter 11, there's lots of really good information here with lots of good examples, and they should all help you find a solution for this guy, which is our discussion. All right, back to week 3. We talked about overview. We went high level over chapter 11, at least the couple of important parts there at the beginning of chapter 11. They do provide us a Java tutorial exceptions link here that is directly to Oracle's site in case you need some more information on this try catch stuff. But if you follow the examples in the book, I don't think, yeah, this gets down into the weeds on some pretty nuanced stuff here, like try with resources and stuff like that. Unless you're really interested, always come back to the textbook. But this definitely gets a little bit further into how complex that exception handling can get. And sometimes that's necessary. Not all the times, but sometimes. Here is a link to the Chapter 11 PowerPoint slides. I've had several students tell me that those are good for studying for the tests or the quizzes, so feel free to download those. All right, let's talk about the nitty-gritty. This is what we have to do for week 3. Discussion forum, programming assignment, quiz, very similar to all the other, well, at least the previous 2 weeks. All right, so if we look at the week 3 discussion, some of you have already started it, and that's great news. They basically want us to take a look at Chapter 11, Programming Activity 1, and try, at least for me, try to complete it. All right, and once you try to complete it, go ahead and answer these 6 questions here that have to deal with file parsing and why it's important in industry. How important it is to know what the format of a specific data file is, all that kind of good stuff. So make your best attempt at solving Chapter 11 Programming Activity 1 and then go ahead and answer these questions. But because this is such an important topic, yeah, well, let's take a look at what in the heck is Programming Activity 1 in Unit 11. They've basically created what I call it a framework, a GUI, that acts like a bank where it will read in an input file of financial information, transactions, and it will basically recalculate whatever the current balance is of that account using that file data. All right. And when you run the program, if everything looks good and everything runs well, then you should see some numbers scrolling past here, and you should see the current account balance update appropriately. All right. So that's what we're looking for. Here is the contents of the transactions.txt file. Notice that it is in a very specific format. Anytime that we're looking at a text file as input, you always want to ask yourself, okay, what is the delimiter? And the delimiter basically means, well, what is the character that separates one field from another field? And here we could see that they use the colon as the delimiter. So this is the description, this is the amount. This is the description, this is the amount. This is the description, this is the amount, okay? But for sure, they're using a colon on each line here in order to, it's called delimit the data, all right? So the delimiter, at least in this particular transactions.txt file, this text file, is for sure a colon. I would say this is a little unusual just because a colon can, the reason I say it's unusual is because text files usually use a comma as their delimiter, all right, not a colon. But the good thing is we get to specify what delimiter we want to use when we are parsing this text file. And I'll show you what I mean here in a second. But really understanding what is inside of your input text file is just as important as writing the code itself. Because if you're off with that and you're trying to make this an integer because you think an integer comes first, but it's a string, it's going to crash the whole program. So with this particular file, with this particular format, we see, well, first is the string or the description, second is the amount, or I guess float or double. So it goes string, double, string, double, string, double, right? We're constantly reading in string, double. If we didn't get that order right, or we didn't get those data types right, it would basically throw an exception, blow up, whatever. So definitely know what your input file looks like and contains before writing code that tries to parse it or separate it. Okay. All right. So inside of, give me just a second. So inside of this programming activity framework, right, for this particular activity, we are supposed to find an accounting drawing file that has a balance checkbook method in it that has not been written yet. And notice that, again, it uses a while loop, right? Anytime we're doing file parsing, unless the file has a header at the beginning, there's always, I don't want to get into that. Usually you're always using a while loop and you're basically saying, okay, is there more data? Is there more data? In this particular case, for this programming activity, we want to use this input file called transactions.txt that they provide for us, right, with this data. And we want to read the contents out of it. As we're reading the contents, we do need to call this animate method that takes these three parameters here, the string that represents the type of transaction, a double representing the actual amount of money, and another double that represents the new balance of that account. All right. So we need to provide these three values to the animate method like this. You should make the call in the body of your while loop after. All right. So this is the idea. This is what we're trying to accomplish. How do we go about doing that? All right. I'm glad you asked. Let's go into our handy dandy GMC virtual desktop. Let's go ahead and open our NetBeans 8.2 and let's create a new project. Java application, give it a nice descriptive name. CIS-211, week 3, right? Week 3, discussion. All right. Leave this as is, leave this unchecked. Because they're giving us the code, go ahead and uncheck this as well. All right. So make sure all that looks good. Click on finish and it should create a nice empty project for you. It does. And at this point, we need the files. All right, well, where in the heck do we get the files? Go ahead and log into the GMC classroom inside of the virtual desktop. Go into your actual classroom inside of the virtual desktop and click on, and remember to do that, just type in this part of the web address directly in order to get to the classroom and go ahead and log in. Then click on this textbook activity framework files. Go ahead and download the zip inside of the virtual desktop. And we are going to open up that zip file. And we should see chapter 11, programming activity 1. Boom. Here are all of the files that we need. That's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 12, 13. All right, so we've got 13 files here. And what we're going to want to do is bring NetBeans to the front. Go ahead and pull open File Explorer with those files, and we're going to highlight all of them. Okay, highlight all of them. And drag, hold the left mouse button down, drag and drop here into the default package, this empty project that we just created, and release the left mouse button. And we should see something that looks like this. It's not happy right now, and the reason it's not happy is because inside of accounting drawing is this nice, wonderful balance checkbook. I assume that's why. Oh, it is happy. All right. This is what we need to implement, balance checkbook. And if we run it right now, just as a gut check, I don't think it's going to do a whole lot. It's just going to be a big blank screen. And so we know we haven't implemented the solution yet. All right, so what does this solution look like? Well, I'm glad you asked, because right before this webinar, I worked on at least a solution, one solution. Is it the only solution? No. But I believe it meets the requirements and it does seem to behave properly. So I did exactly what I just showed you, imported all the files, created that project, and here is where I created the at least one solution that seems to meet these requirements. So we'll talk about these variables here in a second once we hit a line that requires them. But for sure, we're going to need a balance and a current amount. I guess I could have initialized that as well. All right, here's the try, right? Because we're using a scanner that and also a file object, notice I combined the two, we have to use a try, and here's the end of the try. Here's the beginning of the try block, here's the end of the try, and a couple of catch blocks below. And if you don't, let me show you what will happen if you don't use try catch blocks. Let's say I comment out all this code here. Ugh, it's going to get really ugly. Let me not do that. It will complain. The compiler will complain if you don't have that try catch block there. It'll basically say that, hey, exceptions are can be thrown by the scanner guy. Exceptions can be thrown by this file guy, and you don't have any kind of logic to look for those exceptions. So that's why you add this try and these catch blocks, is to accommodate for those exceptions that the scanner and the file object might throw. All right. Notice there's no finally block. I guess I probably should have added a finally block, and I guess we can. Why not? Let's live on the edge. Where, just in case, right, we at least try. All right, that's what I was afraid of. The file guy is local inside here. All right, we'll find them. Let's just do this. Here. All right. Now. Oh no. Well, I guess that's true. So I think ultimately there's a way around this, but I don't have time to do on the fly coding right now. So let's not worry about, let's keep everything as it was. All right. So here is, oh no, I really messed it up. Please hold. Oh, scanner. It was a scanner, not a file. Roger that. All right, so I'm going to get rid of this finally block until I have a little bit more time to look at that. All right, so first things first, we create a new scanner with a file. This is the part that frustrates and confuses a lot of students. This transactions.txt file that we need to open for this particular programming activity is here inside the project. All of these files are inside of the source folder. You would think that when you were to go to open up this file, you could just do this and it would be happy. And look, everything compiles, you don't have any errors, but when you run this, well, let's try it out. When you run this, what you're going to see is that unable to find the file. Not very exciting. If we tell it, hey, it's in the source folder, it will be able to find it. So just know, for whatever weird reason, you need to include the source folder path in front of transactions.txt. And I'll run it here in a second and show you that it can find it. All right. So make sure to always include this in front of your text file, assuming your text file is here inside of your project, inside of your source folder, which it should be. Okay, next we have a while loop that is basically going to look at this file and say, hey, do I have any more data? Right, because this file scanner has a basically like underneath the hood of this scanner, it keeps track of where it is in the file. And as long as there is data, has next will come back as true. So if this comes back as true, it goes into the while loop and says, okay, well, read the next line of data, because I know you've got it. This was true. Read the next line of data, put it into line, and then create another scanner. But this scanner, we're going to pass the line variable, which is a string, not a file. Up here, we're passing the file to the scanner. Here, we're creating another scanner that just where we pass in a single string line object. When we use this single string line object, I'm not sure how that got all wacky there. We want to also tell it, hey, use this delimiter, right? Because if we look at this transactions.txt file, sure enough, there's a colon that's being used to delimit two pieces of information. So we have to tell it, hey, use this delimiter. If your text file has a comma instead of a colon, well then, put a comma here. But the one we're currently using has a colon, so we're going to keep that. And once we tell it what the delimiter is, All right. Now it's able to call next and next double. This is going to grab this part, right? The transaction name. This is going to grab the amount. All right. So this delimiter is super important. The scanner and this delimiter is super important because now we're able to separate, we're able to parse the file and get two pieces of information from each line in the text file. All right. If we were to try to reverse these two lines of code, and this is why I say it's important to know the order in which your text file presents data, well, it's going to crash because the first field is not a double and the second field is not a string. It needs to go string double. So we need to make sure our logic says string and double. All right. Then once we have the current amount that we just parsed out, we can update the balance. And at that point, we can call animate with the three pieces of information, right? Here's transaction name that we got here. Here's current amount that we got here. Here's our balance that we updated here. Okay, we can call animate, and we should see it doing its thing. Once this while loop is done, right, doesn't have any more data left, then it should close that file that we opened up above. If any errors happen, these catch blocks will catch those errors. And just to be on the safe side, I also did a print statement at the end showing us the ending balance, just in case for whatever weird reason this animate method does not. All right. So if we run this, let's try to run this, and we should see something that looks like this. Okay, 200, this is our first amount in the text file. This is our second amount in the text file. This is our third amount, right? Here's the description of each line. Okay, here is our current balance after each one of these different transactions. All right, and at the end, I think we're left with 1,600 or 1,200. Okay, so again, it's going through each line of data. Yeah, $1,500 is, I think, our final balance. All right, so what it just did was it opened this transactions.txt file. It read in this one called animate, read in this one called animate, read in this one, right? And so we're able to create a text file that has all of the input that we need, even if it had millions of lines of data. Well, we have our algorithm here do all the work for us as long as we get our file parsing logic right. Okay. If we don't have our file parsing logic right and we try to reverse, let's say, a couple of these fields and we try to run it, be interesting to see what happens here. Yep. Kaboom. All right. And a lot of you are encountering this. And so, yeah, it is. File parsing is not for the faint of heart. I did it for many, many years, even with binary files and file streams. And if you're off by even a little bit, or your ordering is off by even a little bit, nothing works. So it is a little bit, you have to be very methodical when you're writing the file parsing logic, and you have to know exactly what this file looks like. And a lot of times you have to use the debugger. In fact, let's do that with the first, I don't know, couple entries here. Let's set the debugger. Let's run it. Where's my run debugger? Here we are. All right, and it's going to hit this first line, stop on this first line, and say, hey, try to open up this file called transactions.txt. So when I step over this, what I would expect to see is file over here in the variables window with a good value in it. So I'm going to hit step over here, and I see file, and it does have a scanner object in it with all sorts of crazy stuff that we don't need to be concerned with, but lots of stuff under the hood that it just populated because it was able to find that file. Next, we're on line 60. It says, well, while file has next. here, basically, we just opened the file. We're on the very first line here. For sure, this should be true because we haven't read any data out yet. So it should definitely have data. When I step over this, I would expect to see it go to line 62 just because it has data. All right, so I'm going to hit step over here and hopefully we go to line 62. If it jumps down here to 75, well, that means that the file doesn't have any data in it. All right, so I'm going to hit step over here. All right, it goes to line 62. So it did find data. Now on line 62, it says, all right, well, read out the next line of data. Well, we're at the top of the file, so I would expect it to read this entire line here. So when I hit step over here on line 62, I would expect to see a variable called line over here with that entire line of data right here. Check number 13, negative 200. So I'm going to hit step over here, and sure enough, here is the line variable. And yep, check number 13, colon, negative 200. All right, so that works. That makes sense. So then here on line 65, it's going to create a new scanner and pass this string to it. So when I step over 65, I'd expect to see a new variable called st that has this string inside of it. And we see that, yeah, we do have a variable called st that is a scanner. I don't know. I guess we could dig in a little bit more to see what the actual data it has, but there's so many. I mean, there's so many variables that, here it is. No, that's the wrong variable. So at least at this point, we've verified we've created a new scanner called st, and it didn't throw an error. Here on line 66, we're going to tell it to use the delimiter. So when I step over here, I would expect it not to error out, and somewhere under the hood, it set this delimiter to the colon. Now, because this is colon, here on line 67, we're saying, hey, take this scanner guy called ST and grab the very next string. That's what next means. Grab the next string. And in this case, it should be this, check number 13, because the colon is the delimiter. So when I step over line 67, I would expect to see transaction name over here set to check number 13. So let's see. Yep, sure enough, transaction is a string with check number 13 in it. So this line of code worked. Then 68 says, all right, we'll grab the next piece of data out of this ST scanner guy and make it a double. Well, yeah, I guess that makes sense. There's a negative 200 here. That does look like a double. So I would expect to see current amount here change from 0 to negative 200 when we step over this line, 68. Let's see if that happens. Sure enough, 68, current amount, negative 200. So that line of code works. And at this point, we know current amount is negative 200. We're going to add that to balance, which is 0. When I hit step over on 71, I would expect that to change to negative 200. And balance has been updated to negative 200 because of this line of code. Well, that makes sense, even though I'm not sure why the bank is allowing an overdraft of $200, but we won't talk about that. And then finally on 73, it calls the animate method with the proper transaction name, the proper current amount, and the proper balance. And inside the debugger, we're not really going to be able to see what animate does. That is one of the limitations when you're debugging. You don't get to see the graphics happen in real time. So we're just going to have to trust that this works. And then when I hit step over here, it should come back up here to the top of the while loop. And it should say, hey, is there more data in the text file? Well, you bet. We just read in this one line of data. There's another one here. So this is going to be true, right? And at this point, it's going to read in the next line. I would expect that to be here. Check number 14, negative 100. So I'm going to do step over here. I would expect to see line equal to that information. Sure enough, line is equal to that information. And then we're going to run through the whole parsing logic again, where we're going to rip out check number 14, put it into transaction name, right? Tell it to use the delimiter again. Transaction name is check number 14. Current amount, what is that? Current amount is negative 100. So I'm going to hit step over here. expect to see current amount equal to negative 100. And if we add that to the current balance, well, my gosh, now the customer is going to be negative 300 in the hole, but so be it. Balance is updated to negative 300, and then we do the animate. So you can see how stepping through this code gives you a lot of insight into what's going on behind the scenes of file parsing. And you got to get really good at the debugger in order to, in industry, in order to accomplish programs like this that do a lot of file I/O. Otherwise, it's a complete guessing game, and you're going to get super frustrated. All right. So definitely need to get good at the debugger in order to find a solution to the file parsing logic. Whew. Okay, so that is a solution, one solution for the discussion this week, Programming Activity 1. I hope that this helps, because knowing this is going to help you for the programming assignment. Oh, well, excellent lead-in. What else do we need to do for this week? Oh, yes, the week 3 programming assignment. What does that look like? Well, very similar to our programming activity that we just talked about. Only difference is we've got a text file with this information instead of the transactions.txt file. And notice it's a little bit different, right? We've got commas here instead of colons to separate each one of these fields. So that's the first observation we need to make, is that, okay, this is a comma delimited file, text file. The other observation is, well, wait, each line has 4 pieces of information. Well, what the heck are those 4 pieces of information? Aha! First field is the employee name. Second field is the hourly wage. Third field is the hours worked. And then finally, the fourth field is the parts tested. So when we parse each one of these lines, we need to parse out each one of these 4 pieces of information. All right? And once we parse out this information from the input.txt file, we want to output it to the screen, right? We want to output it to the screen, and we want to give it a format that looks like this. Notice that we are expected to calculate the total pay just by looking at the hourly wage times the hours worked, right? This total pay is not given to us inside the file. Maybe that's the whole reason why we're creating this application, is so that we can create all of the employees' total pay, right? So we're provided these 4 pieces of information. Oops, excuse me. 1, 2, 3, 4 pieces of information in the text file, but we need to be able to calculate and display this total pay for each employee. Okay. All right, so that's the idea. How do we go about doing this? Well, I'm glad you asked. Let's go to our handy dandy remote desktop. Let's go into NetBeans, as we always do. Let's create a new project. It should all feel very familiar. Okay. Please do not try to reuse projects. You will not be happy. Give it a nice descriptive name. What is this week 3 assignment? Here, leave this as is. All right, you have read and write privileges to this folder. Leave this unchecked. Here we want to check this, but get rid of all this package information in front just to make your life easy. In industry, you probably would want to group all of your classes into their own individual package. But in order to simplify our life here, we're going to put all of our files into this single default package. Okay, and we're going to call our main class, what do we need to call our main class? It wants us to call our main class FileReport.java. FileReport.java. So that is what we are going to do. We are going to call it FileReport. And it's automatically going to add the .java, so I'm not going to add that. We click on Finish, and we should see a nice new project with a nice new Java file with a nice new main method that we can start with. All right, and again, I would like you to add comments, but I just delete those to show you what uh, the essence of what it is that we're trying to do here. So here is our new class called file report, but notice that it also wants this text file, right? And it's not provided. So how the heck, I get a lot of questions from students, where do I find this text file? Well, you create it, and let me show you how you create it. Probably the easiest way is inside of your project, inside of NetBeans, right-click on this default package here and say New, and if you don't see empty file, go to Other here, Other, and select Empty File here, and go ahead and click on Next, and let's name it, oh my gosh, what do they want us to name it? Input.txt. How original. Input.txt. Here you do want to include the extension. All right, leave it in the source folder. Go ahead and click on Finish. All right, new empty file, input.txt. And here, inside of this file, well, let's just copy and paste the data. And in industry, I would probably add more data than this, but at a minimum, this is what they want us to do. And here is the text file that is comma delimited, right, with the two records of information that they give us. All right, so this is where you should start. Well, that's fine and dandy, but how do I go about creating this algorithm that is going to read that file? All right, so before this webinar, I worked on a guidance project concerning week 3, and I would like to show that to you. And again, this is one possible solution. Is it the only solution? And the answer is no. But in case you're struggling where to start here, make sure that, yeah, you put a comment header at the top explaining what assignment it is and which file this is. That is always good to have. Okay, so here is my guidance. Inside the main file, inside the main method of file report, yeah, you need that scanner, right? Remember the scanner guy that we looked at in programming activity 1, and for sure we need a file scanner that's going to open up, right, this input text file, right? Very similar to, let's go back to programming activity 1 here. Very similar to this guy here, right? But instead of transactions, we're using input.txt. Make sure that you also use the source subfolder in front of it. And this is a forward slash, not a backslash. Every OS is a little bit different. If you're on a Mac, you might need to use a backslash. All right, so make sure you create the file. Create a loop, right? We need to call hasNext to make sure that that file scanner has data for us to read in inside of that while loop, right? Very similar to this here. And then let's read in one line of data and put it into a variable, right? Very similar to what we do here. Read in one line of data. Let's tell it that let's create another scanner that's going to use that one line of data, right? Call it line scanner. Very similar to this guy here. Okay. Create a new scanner for that line that we just read in. So this is the second scanner. We're going to tell that line scanner which delimiter is being used, right? Because in this case, in input.txt, we see that a comma is being used, right? So we need to tell it to use a comma as a delimiter. All right, this line scanner, tell it to use a comma as the delimiter. And then you basically retrieve each one of those fields, the employee name, the employee hourly wage, the hours worked, parts tested, and that is all very similar to, right? This now notice here it's only reading out 2 fields, right? Because each line inside of that text file only had 2 fields. Here we've got 4 fields. So we need 4 lines of code to read out those 4 fields using that line scanner. And you got to figure out, well, are you reading a string? Are you reading an int? Are you reading a double? Make sure you know what each one of these fields is. Is it a string? Is it a double? Is it an int? All of that is important here. Once you have those 4 pieces of information, well, now we can calculate the total pay, right? Using hourly wage, using hours worked. We can multiply the 2 together, and bada boom, bada bing, we've got our total pay. So we're going to store that in a variable called total pay. And at that point, we've got everything we need, and we can just print out all that information that we just extracted from the file that we just calculated, right? We can calculate all of that and put it into and print it out to the screen. And you're going to keep doing that until you read all the lines of data from the input txt file, which in this case is 2, but I would suggest try adding a few more, a couple more lines of data with some random values, and make sure that that works as well. Yeah, important note here. You do need to add try-catch logic, right? Because we are using a file scanner with a file object. And I guess you can try not to, but you're going to see all sorts of compiler errors saying, hey, these guys throw exceptions. I don't see any try-catch logic. You need to update your code. A good example of that is here, right? Here's our try. Here's the end of the try. Here's at least the 2 exceptions. I believe you need to implement at least these two catches, file not found and just the regular exception, and then it should be happy. I don't know if you need to add a third exception, but you might. Okay, and that's basically it. So it's not a lot of code for sure, but you got to be right. Every line of code needs to be correct, and if you try to develop this code and you're getting errors, just try to add 1 line at a time and make sure that it's doing. Use the debugger, right? Add the breakpoint in the debugger and step through it, like I showed you how to do with programming activity 1 to see what's going on, because otherwise it's just a guessing game and you're going to get super duper frustrated. All right, so that is my week 3 programming assignment guidance, I guess. All right, if you know of another way to do it, by all means, feel free. If you don't know how to get started, I would suggest utilizing this guidance here. Whew. Okay, what else? Right, the week 3 quiz. And week 3 quiz is the usual 10 questions, 4 open response, 25 minutes, 1 attempt at the quiz. Make sure this is done by Sunday at midnight. I guess the last final thing I'd like to say is remember that your results document, right? Copy and paste this code into it. Copy and paste the output window with the timestamp. But the third thing I need in that results document, well, I guess I don't need it because it's assumed. Well, no, I do need it. If you add data to this input.txt guy, I need to know what this input.txt guy looks like. So please copy and paste and show me what your input.txt file looks like inside of your results document also. That would be very, very helpful. All right. And when you go to turn it in, zip up the Java file and the txt file. All right. Whew. Okay, so I know it's a lot. We're definitely getting down into the fun stuff, but this is all very industry relevant. For sure, they are going to want you to have file I/O experience. We're using text files here. Plenty of organizations use text files, but they also use binary files. The binary files, as long as you know how to parse a text file, binary file is similar, and it is described in Chapter 11 if you want to look into that. But for sure, at a minimum, you need to be able to do text file I/O. All right. So with that said, I guess that's the end of this week 3 webinar. Please continue to leave feedback, like the video, comment, whatever, send me an email. That's what helps me make these webinars better. But anyways, have a great rest of your week and reach out if you need anything at all. Thanks.